ThinkCentral Lesson 8:15 is all about attributes of a triangle. So in this lesson, we're going to be studying about different types of triangles and their characteristics. Let's start off with a fun song, teach us about different types of triangles. Press play to learn more. So let's review these. We're in the song. We've got a scalene triangle up here. Highlight that for you. Scalene triangle right here. Scalene triangle, all sides are different, and all measures of angles are different. You can see in the example, you see the lines of congruency over here. That means that when the lines are different lengths, or there's different numbers of them, that means they're not congruent. So you have 3 non-congruent angles and 3 non-congruent sides, therefore it's scalene. An isosceles triangle is a triangle that has 2 congruent sides, and by definition, 2 congruent sides also means 2 congruent angles. So that's an example of that one. Equilateral triangle right here would mean that all sides and all angles are congruent, and you can tell looking at the marks of congruency, 1, 1, and 1, they're all congruent, and all angles have the same measure of 60 degrees. A right triangle is a triangle that has 1 right angle, and you indicate a right angle by the little square in the corner showing a right angle of 90 degrees. You can also have an isosceles right triangle, or you can have an isosceles, well, you can have a scalene right triangle or an isosceles right triangle. An obtuse triangle is a triangle with 1 obtuse angle, and an obtuse angle is defined as greater than 90 degrees. A right triangle is not obtuse. It has to be an obtuse angle has to be greater than 90 degrees. An acute triangle is a triangle with all angles less than 90 degrees. And you can see 2 examples of those right here. You can have an equilateral triangle that is acute because all angles are less than 90 degrees. So as in previous lessons, you see that they're asking us to define the statement as true or false. If it's false, find a picture that shows the counterexample of the reason why it's false. The statement is all isosceles triangles are equilateral. Well, I know that that's not true because only 2 sides have to be congruent for it to be isosceles. And you see here that this is an isosceles triangle, and it only has 2 congruent sides. So equilateral triangles are not isosceles triangles. So A serves as a counterexample to that statement, making it false. The statement here is all right triangles. Let me highlight that for you. All right triangles have 2 acute angles. Let's take a look at these. A, the statement is false. This is a right triangle here, and it does have 2 acute angles. Item number B, the statement is false, but it gives no reasoning why. And item number C, the statement is false, gives no reasoning why. And item D says the statement is true. Well, A is the reason why all right triangles have to have 2 acute angles. If you remember in the video, it said that all triangles are made up of 180 degrees. So if all triangles have 180 degrees in them and a right triangle has 90 degrees in them, then if you take away 90 degrees from 180, you end up with 2 angles that would have a sum of 90 degrees. So by definition, an acute angle is less than 90. So you have there are 2 remaining angles. As an example here, you have the right angle, and you have the 2 remaining angles, and they together must be equal to 90. And since no angle can be 0, then they have to be 2 acute angles. So it is true. I would say the statement is true. All right triangles have at least 2 other acute angles. D. All right, next problem. I know right off the bat, all equilateral triangles are acute. And that has to be true because equilateral triangles, by definition, are a triangle with 3 acute angles and 3 acute and 3 congruent sides. Again, the total of degrees and a triangle is 180. If you have three angles that are congruent, that means they're all the same. So basically 180 divided by 3, each of those angles, in this case, an equilateral triangle will be equal to 60 degrees. And 60 degrees are all acute angles. So all equilateral triangles are also acute angles. Question number 4, they're asking us to find a shape that shows an isosceles triangle, meaning two sides are congruent, and a right angle. So answer A is not possible, maybe, but I don't think so. B, it does show a right angle here, but it does not give us lines of congruency here and here. So we don't know if these are the same size and length or not. But option C, we do see that it has a right angle, and it shows us that it is also an isosceles triangle because two sides are the same. Option D, it shows that it is an isosceles triangle, but it doesn't give an indication of what the measurement of that angle is right here. So we don't know if this angle is right or not. The only way you can tell if it's a right angle is by measuring it with a protractor or looking for the box in the corner. So correct answer is C. Question 5 is asking us to select shapes that show a triangle with more than one line of symmetry. So I've gone ahead and I've posted this definition for you down here, what a line of symmetry is. Another name for that is a reflection, or basically there's two halves that are exactly the same. So you could cut an object in half or cut it down a line of symmetry, and the left part of that picture and the right part of that picture would match exactly. The example would be this dog right here. So looking at this, it says the question, first option A is not possible. Second option B, can I cut this triangle down the center more than one way to give, using a line of symmetry, to more than one way? And yes, I can cut it down this way. I can also cut it from this vertex down to the center. And as a matter of fact, I can also cut it from this vertex here down to the middle, so down to the middle of that other side of the triangle. So this would actually have three lines of symmetry. This isosceles triangle would only have one line of symmetry going like this, because there's no other way I could cut it. So both halves are the same. And this triangle here, that is a scalene triangle, and it has no lines of symmetry because I cannot cut that triangle any way, shape, or form that will give me two halves the same. So it is possible to have a triangle with more than one line of symmetry, and it is B, an equilateral triangle. The following will be a set of questions where we're identifying attributes of different triangles and then placing them in categories. So as we go through the problems, it's really important that you make a table to keep track of what you have to kind of go, triangle by triangle and list the attributes. And if you have that table, then it's super easy to solve these problems. Without the table, you're going to miss one for sure. All right, so the first thing they're asking us to do is which triangles are right triangles. So you notice you have all these different triangles up here at the top, but I have created a table down here. So as we go through them, you just say yes or no and tick them off. Now remember, the only way that you can tell if it's a right triangle is if it has that square in the corner. Without that square, you'd have to measure using a protractor, but ThinkCentral doesn't expect you to do that. So just look for the ones that have the square. What you see is B is a right triangle. Triangle I is a right triangle, and L is a right triangle. So based off of that, there are only three right triangles: B, I, and L. So for the second category of these triangles, they want us to identify triangles that are right isosceles triangles. And remember, for an isosceles triangle, we're just looking for those marks of congruency. So we need triangles that are right and isosceles. So since B, I, and L were the only right triangles, those are the only ones we need to be concerned with. So which of those are right and isosceles? If you look at B, you don't see any marks of congruency in B, so that one's out. If you look at I, again, you don't see any marks of congruency on the side, so that's also out. And if you look at L, you see that there it is a right triangle and there are 2 marks of congruency. So the only triangle that is right and isosceles is triangle L. Now they're asking us to find all triangles that are neither right nor isosceles. So we're looking for all the triangles that are not right triangles. Any triangle that has the right angle indicator would not apply here. So out. So all the ones in previous lessons don't apply. So those are all out. And we are left with the following triangles. So I've crossed out the ones that are not right triangles, and I've put a check by all the ones that are right triangles. So now I'm looking for ones that are not isosceles. So any isosceles triangle I will also take out of the possible answer. So looking at this, A is an isosceles triangle. So that eliminates that because we're looking for triangles that are not right and also not isosceles. E is isosceles, so that's out. G is isosceles, so that's out. H is isosceles, that's out. And we are left with these four triangles left: C, D, 5 triangles: C, D, F, J, and K. So let's look at triangle C. Now we know that that's equilateral, but the question that I asked myself is an equilateral? It does have 2 sides that are congruent, but it actually has 3. So is an equilateral triangle also an isosceles triangle? I didn't know the answer, so I had to look it up. I Googled it, and here's what I found. So the answer says an equilateral triangle is one with 3 equal sides. An isosceles triangle, it has 2 equal sides. Therefore, every equilateral triangle is also isosceles, but not every isosceles triangle is equilateral. So yes, the answer is true. An equilateral triangle is also considered isosceles because it has at least 2 equal sides. So that being said, we get back to our problem. So C would be isosceles. It's equilateral, and that means isosceles. D, so I would eliminate C because it is isosceles. I'm looking for triangles that are neither right nor isosceles. D is not a right triangle and also not isosceles, so that is a correct answer. F is not a right triangle and also not isosceles. J is an equilateral triangle, therefore it makes it isosceles, so J is eliminated. And K is not a right triangle and it's not isosceles, so that would be an answer. So our 3 correct answer for this problem, when we categorize triangles that are neither right nor isosceles, would be D, F, and K. A little bit easier on this, we're looking for all the triangles that are obtuse. That means they have one angle that is greater than 90 degrees. So let's take a look. A looks to be obtuse. This angle looks to be much greater than 90. Now it's really hard to tell on these because you don't have a protractor to measure it, but so you have to kind of eyeball it. But A definitely looks to be obtuse. B is a right triangle, so therefore it's not obtuse because the other angles have to be acute. C is an equilateral triangle. All 3 angles are acute. D, this is less than 90, this is less than 90, and this is less than 90 because if it was a 90-degree angle, it would go like that. So D is acute. E is acute isosceles triangle. F, if you look at this angle here, that is obtuse. So that is an obtuse triangle. These are all smaller than 90. This one I can't tell, but it appears that if it was a right angle here, this would be greater than 90. So I think that angle there I think this angle here is obtuse, so I would include that as an obtuse angle. This is a right triangle, so that doesn't count. Equilateral, they're all acute. This one appears to be greater than 90 here, so I'd say that's obtuse, and this is a right angle, so that it is a right triangle. So what we're left with is triangles A, triangle E, triangle H, and triangle K as our obtuse triangles. So I cleaned it up a little bit. Actually, I went back and I saw that I had marked E. This is how confusing it can be, but E is definitely not obtuse. So I ended up with 4 triangles A, F, H, and K as my obtuse triangles. Again, organization is key on this. Hopefully this one will be a little easier. You're looking for the scalene triangles. That means all sides are different. You can tell that because any sides that are the same would be marked with congruency. So A is an isosceles triangle. They're not all different. B appears to be all different. C is equilateral. They're all the same. D is all different. E is isosceles. F is all different. G is isosceles. H is isosceles. I is all different. L is isosceles. K is all different. J is equilateral. So we are left with triangles B, D, F, I, and K as scalene triangles. All right, now they're asking us to find the triangles that are obtuse and scalene. So if we look back at our obtuse triangles, we remember that triangles A, F, H, and K were all obtuse, but now we're looking for obtuse scalene. So A would not apply because A is isosceles, so A would not count. I would cross that out. F is scalene and also obtuse. H is not scalene because it has 2 lines of congruency, so that one is out. And K appears to be scalene and has 1 obtuse angle, though I can't really tell. So I'm going to answer those as triangles F and K are both obtuse scalene triangles. All right, so it's the flip side of the last problem. They're asking us to find triangles that are neither obtuse nor scalene. So let's first identify all the triangles that are not obtuse. So looking at these triangles, I came up with these triangles here are obtuse, so they would not count. So that leaves me with to consider B, C, D, E, G, I, J, and L. Though I'm not 100% sure on K. K might be obtuse and it might be acute. I really can't tell to measure this angle. So now we're looking for of these ones, which ones are scalene, all different. So we see that B has all different sides. So B is both not obtuse nor scalene. So let's look at triangle B. Triangle B is not obtuse, but it is scalene. So I'm going to eliminate that one. B is out. C is not obtuse, and it's not scalene. So I'm going to keep C as a triangle for an answer because it's not obtuse and it's not scalene. D is not obtuse, but it is scalene, so that's out. D is out. F is not obtuse, and it's not scalene because it's isosceles, so I'm going to keep that one. So E is a check. F is not obtuse, and it's not scalene, so that is a keeper. I is not obtuse, but it is scalene because all these 3 sides are different. All these 3 sides are different shapes or different sizes, so I'm going to eliminate that one because it is scalene, and we're looking for not scalene. And J is not obtuse, and it's also not scalene because it's equilateral, and L is not obtuse, and it's also not scalene, so I'm going to keep that one. So the answers to this question should be C, E, G, J, and L. That's the end of lesson 815 about triangles. So keep practicing and let me know if you have any questions.